can we use the concept of the potato battery with a few different chemicals and improvements to make an actual battery? Let's find out. Okay, ladies and gentlemen, so we are taking the potato battery that we made in the last video and we're going to upgrade it to potentially a battery that we could actually use. So, to do this we need a copper electrode, a zinc electrode, sink and drain unblocker, which is made out of sodium hydroxide, and a container to put it all in. I'm just going to use a little shot glass today, because the tray that we used for the potato battery was a bit big, and it did in fact leak everywhere. So let's start off by grabbing our shot glass and putting on our rubber gloves. Now, take your sink and drain unblocker, undo the cap very carefully and pour in about half a shot glass for this experiment. As you can see, this type is the gel type, which is slightly thicker than water. Do the cap back up nice and tight. If you hear that click, then it means it's on tightly enough. Then grab some water. This is just normal spring water. Same type that we used in the last video. And just top up the shot glass with a bit of water and then give it a little stir. There we go. Now all that's left to do is grab your electrodes and put one on in each side of the liquid. Now if you drop the zinc electrode, in this case, fully into the liquid, then you are screwed because I'm not putting my fingers in there to get it back out. Now let's measure the volts of this cell, since this is only a single cell and not a battery, which is several of them in series or parallel. And we get around about half a volt. Now the stronger the acid you use, i.e. the less water you put in, the higher the voltage. I have another one which is just the sink and drain unblocker, and that reached a volt exactly. Now turn your meter to amps mode and make sure it reads 0, and then essentially short circuit your cell and see what current you get. As you can see, it downward trends quite quickly to about 1 milliamp. Now that is still a dramatic improvement over our potato battery, which couldn't even deal 1 milliamp. Let's try this experiment again. Take out your electrodes, go to the sink and wash out the shot glass. Now then, take your shot glass and a new nail. You can use the same copper electrode, just like I will, because that does not corrode while the zinc electrode does. And fill up your shot glass again with sink and drain unblocker, but this time fill it all the way, or most of the way, but don't add any water to dilute it. There we go. So now that we've added our electrolyte, let's add our copper back in and our new nail. There we go. And now let's measure the voltage again. Now because it's an increased concentration of acid, we should get a higher voltage out of our cell. There we go. Almost a volt, which, while comparable to our potato battery, it has a much higher current. Now let's give that a try and see for ourselves. So switch the meter to current mode and short the battery. You can see it reached almost 100 milliamps there. And it's stabilizing around 10 milliamps and is gradually falling. Now that is because of the high concentration of acid. The zinc is actually dissolving from the nail and is slowly transferring to the copper, is why you can see that slight grime on the copper electrode. So, ladies and gentlemen, thank you very much for watching. If you got this far, thank you ever so much. If you gave this an attempt yourself, then please let me know. I really want to see what your outcomes to the experiments were. And if you know any improvements on this design, then please also let me know. I might make a video continuing this improving a battery series, so to speak. And I shall see you in the next video. Goodbye.